Hello everyone, I'm David Quinn, a research scientist at University of Wisconsin-Madison in the Macrostrat lab. I'm going to talk to you today about building a new generation of user interface tailored to field geological mapping. This has culminated in the Mapboard GIS iPad app, which is in beta. For more information on how to try out the app, you can head to davidquinn.com/projects/mapboardgis. So this saga started for me when I began a field mapping project in the Naukluft Mountains in southern Namibia, which is a series of fold and thrust naps from the Neoproterozoic to Cambrian Damara origin. At the Geological Survey in Windhoek, Namibia, you are confronted with a wall-sized, pencil-drawn version of this map of the Naukluft Mountains. It's an imposing work and a good set piece to consider the role of hand-drawn maps in our geologic mapping process. Hand-drawn maps are the standard for geologic maps, as they have been since their inception, and for good reason. In addition to being technically approachable, hand-drawn maps have a tactile nature that makes them very amenable to building understanding of geologic relationships and phenomena by mimicking them on the page. While learning structural mapping in field camp, I rubbed maps on my Mapboard raw with eraser, trying to capture a field pattern that matched what I saw. This iterative mapping process proved highly effective for me, and it's a tactic I continue to employ to this day. When I arrived in Namibia in 2015, I had this paper-based mapping workflow in mind. I basically printed an atlas of field maps because this was an exploratory project and I didn't quite know where the relevant detailed mapping would be. I spent about $140 to print out about 30 20K map sheets and some other index sheets, and spent a lot of time organizing this effort. And then when I got there, I spent a lot of time taping different map sheets to map boards. This started seeming a little anachronistic, since most of the maps that we interact with in daily life are by now totally scale independent. Even on my iPad in the field, I had a high-scale base map where you could resolve individual trees, and, just as a digression, you could see zebra paths that turned out to be the best paths down from the plateau. But my paper-based mapping workflow kept me going through my first field season. I moved around between different field sites on the edge of the plateau, using a different base map at each site, and built the regional picture by digitizing points for hours in my tent using QGIS until my battery would run out. So in this context, after my first field season, when the Apple Pencil came out, it basically blew my mind. It seemed like by far the best tool to do high-precision regional mapping at multiple scales. So I bought an Apple Pencil and an iPad Pro, and first tried this in Field Move, and it kind of worked, but it quickly became apparent that you couldn't do that much work or that quickly with it. So I corresponded with Midland Valley to see if they would add a few features to make Field Move a better platform for pen-based digitizing, and they suggested that they weren't interested in future development. So with a classic amount of graduate student hubris, I rolled up my sleeves, started to learn Swift, and started building the field mapping app that I wanted to see. Mapboard GIS is a streaming digitizing app for the iPad and Apple Pencil. It wraps a sophisticated GIS backend under simple editing tools for drawing and erasing different line and polygon types. It also has snapping capabilities for closing line work, the ability to add and remove line types, and to add different units as polygon swatches. It also integrates a layer switcher and allows the ability to set different base maps. The simple editing tools provided by Mapboard GIS make it easy to do even complex operations using the onboard Spatialite backend. When using typical field mapping workflows, the transition to desktop map production is a time-consuming process. Mapboard GIS typically runs in a field mapping mode using an onboard Spatialite database that can easily be read by desktop GIS software. But it also has a couch mapping mode, where it runs tethered to a computer and a PostGIS spatial database. This enables mapping at larger scale using the greater power of a desktop GIS system. It also enables collaborative mapping and direct real-time interfaces to ArcGIS and QGIS. In tethered mode, Mapboard GIS functions identically to how it functions standalone, but it can load much larger datasets due to co-processing with the more powerful computer. You might suggest that between desktop GIS software and emerging field GIS tools, there are plenty of programs with stream digitizing capabilities, so why add another one? And it's hard to overstate how important having a simple user interface is to effective and quick editing. This example of Touch GIS shows the common GIS problem of falling back to point-based editing for all operations. But the problems of traditional GIS workflows for geologic map production actually go much deeper. This tutorial on how to construct a geologic map in ArcGIS from Roman DiBiase's Geomorphology Lab is a good example of that. Not to pick on Roman, this is one of many similar tutorials that I've found, and it is aligned with best practices. The instructions cover the steps of loading data into ArcGIS, closing and snapping line work, and then constructing polygons, and then how to lay out and design your map. But as we scroll down through this, all we're seeing is dialog boxes and checkboxes, and more dialogues. And at one point, there's a point on a map, and so on. We're not seeing very many maps in this process. The whole workflow is time-consuming and very incompatible with iterative mapping. We eventually get to a geologic map, but it needed to be fully defined before we started the digital process. Topology is a property that geologic maps share with other space-filling planar graphs, and it's the reason why you usually have to solve the line work of the map before adding polygons. The polygons must be mathematically solved from the line work. Mapboard GIS has a built-in iterative topological solver, making it possible to solve the line work of a geologic map as you draw it. This is a geologic map of the Hurricane, Utah, and Zion National Park region. And here we're drawing new unit polygons in areas not covered by our original map. We can enclose areas with line work and change the units within those areas. And the polygons will snap out to fill the space bounded by these contacts. Then we can add another enclosing polygon around this mesa and assign it to the correct map unit. We can do the same for an area of probable colluvium. Then, moving to our previously digitized line work, it's possible to change the map that has already been created. We can also add new polygon types and detach topology segments. This is a really powerful tool, and in my opinion also extremely good for teaching because you can show students how to create a geologic map and have them see the results returned to them in near real time. All of this topology work can be done using the onboard spatialite database in Mapboard GIS, but the really effective way to work with topology is to use the fully realized version of the tethered mapping mode with a topologically enabled PostGIS database. Another project that I have created that is closely related to, but independent from Mapboard GIS, is this PostGIS geologic map project, which manages a schema and an iterative topology solver that can work with any GIS system. Here is an example of PostGIS geologic map being used within QGIS at the Wisconsin Geologic Survey. Using Mapboard GIS in conjunction with PostGIS geologic map allows you to solve topology in real time, even for very large geologic maps. The Mapboard GIS app has been used in conjunction with the PostGIS geologic map topology solver in several mapping projects by myself and collaborators. This preliminary geologic map of the southern Nowclift Mountains, some of my PhD mapping in Northeast Syrtis Major, Mars, and finally, a large-scale collaborative mapping project at Little Ambergris Key, Turks and Caicos Islands. I think Mapboard GIS has path-breaking capabilities that illuminate the possibilities of good user interface design to inform better workflows in the geosciences. The next steps for this project are a variety of performance fixes and optimizations, a few new features, and most critically, a public App Store release. But for now, you can check out the beta app on test flight. So head to daveandquinn.com/project/mapboard-GIS for more information, and thank you very much for listening.